Welcome to Mr. Benjamin's Math World. Today we are going to focus on identifying types of trinomials. We need to first identify what type of trinomial it is in order to factor it. If you do not know what kind of trinomial it is, you will not be able to factor it. Therefore, we have this trinomial, three terms, 1, 2, and 3. First, we need to know what kind of trinomial it is. This trinomial is called a perfect square trinomial. Why is it called a perfect square trinomial? 3 steps in order to identify it. Because first we need to know the name. Once we know the name, we know how to factor it. It's a perfect square trinomial because of these 3 simple steps. Number 1, the first term has square root. The square root of x to the second power is x, as we know. Second step, the third term also has square root. The square root of 64 is 8. And the final step is the second term must be always 2 times the square root of the first term times the square root of the third term. If we multiply 2 times x times 8, we get 16x. Once you know that, then you are able to factor it. How do we factor it? How do we factor a perfect square trinomial? Just like this. Open parenthesis. You get the square root of the first term. Here it is. X to the second, the square root is x. Here it is. We copy the sign of the second term, which is a negative sign. And then we get the square root of the third term, which is 8. Close parenthesis to the second power. It has already been factored. Now, how can we prove this? Well, like this. If we get x minus 8 to the second power, it means x minus 8 times itself times x minus 8. Let's make it easier. If we say 5 to the second power, 5 to the second power, it equals to 5 times 5, which is 25. Here we have the same process. So here we have equals x minus 8 times x minus 8. There's no need to do this. We are just trying to prove that this trinomial, when factored, we get the same result. We have this, and now we FOIL it. We use the FOIL method. If we remember the FOIL method, it means first, outer, inner, and last terms. So we are multiplying by using the FOIL method. Let's multiply. X times x, x to the second power. X times negative 8, outer terms, negative 8x. Inner terms, negative 8 times x is negative 8x. And last terms, negative 8 times negative 8 equals to positive 64. And now we have these 4 terms, which can be also simplified further because we have some like terms here. In the like terms, we know them. These two are the like terms. So I'm going to solve this. Bring down the x to the second power. Negative 8x minus 8x equals to negative 16x. Why is it negative 16x? Because we remember the rule. We know the rule. It says, in addition or subtraction, when we have the same signs, we add the numbers and we just copy the same sign. That's why we get negative 16x. And bring down the plus 64. And we get the same result as the trinomial above. And this is how you factor a perfect square trinomial. Let's see our second trinomial. If we look at it, I immediately see that it is not a perfect square trinomial. Why not? Because we said before, the first term has square root. It does have square root. The third term also has square root, but 15 does not have square root. That's it. It is not a perfect square trinomial. So this one cannot be factored as a perfect square trinomial. How is it factored then? Like this. This applies for this trinomial. We need to find two numbers. When we multiply those two numbers, we get the third term. And when we add or subtract those numbers, we get the second term. Again, when multiplying those two numbers, we get the third term. And when we add them or subtract them, we get negative 8x. Have you figured out the numbers? Two numbers that multiply get 15. And when you add them or subtract them, you get 8. I got the numbers. They are 5 and 3. Because 5 times 3 is 15. And 5 plus 3 is 8. Don't worry about the sign yet. Once we have this, we also get the square root of the first term, which is x, in both sides. This is the easy part, because we just figure out what numbers apply to this condition. In this case, again, we're multiplying these two numbers always. So multiplying those two numbers, you get the third term, and when you add them or subtract them, you get the second term. Here I got the numbers. Now, I need to figure out what signs I'm going to use here, because here, according to the trinomial, it says that when I multiply these two numbers, I'm supposed to get positive 15. If I get positive 15, it's because of two conditions. If this is positive and this is positive, when multiplying positive times positive, we get positive. The first condition is okay so far. But also remember, when you add them or subtract them, you get the second term, which is a negative number. And then if this one is positive and this one is positive, and you add them, you add positive 5 plus positive 3, you get positive 8. And this one is not positive. So now I know that the signs cannot be both positives. What happens if I use negative and negative? Why? Because we know that when multiplying negative times negative, we get positive. So this might be also a good one. It might be negative and negative. Let me use them. Let's see what happens. If I multiply negative 5 times negative 3, I get positive 15. The first condition is okay. The second condition, when we add negative 5 plus negative 3, the rule of the signs say when the numbers have the same signs, you add the numbers and you copy the same sign, and therefore this will be 8 negative. I got the numbers. This is correct. This is the way it is factored. Once it's factored, if we need to prove that this is correct, No need to do that unless you are asked for it. Just let's use the FOIL method. First terms, outer terms, inner terms, and last terms. Let's use it. X times x, first terms, x to the second power. Outer terms, x times negative 3, negative 3x. Inner terms, negative 5 times x is negative 5x. Last terms is 2. Negative 5 times negative 3 is positive 15. Do I have any like terms? Yes, I do. Here they are. So I need to solve the like terms in order to reduce the trinomial to its simplest form. Just bring down the x to the second because I don't have any other like term. I don't have any other to the second power, x to the second power. There's none. So just leave it like that. Bring it down and solve this. It says negative 3x minus 5x. And this is, it's important to understand. It's important to differentiate when you are adding or subtracting. In this two, there's no multiplication because see, you have negative signs. They are just subtracting, you see. So the rule that needs to be used in this case is the rule for addition and subtraction. It says when the numbers have the same signs, here they are, you add the numbers and you copy the same sign. So I'm going to add 3x and 5x, which is 8x, and I copy the same sign. What same sign? The negative sign. It's the same one for both. And then just bring down the positive 15. And here it is. To wrap this up, a perfect square trinomial, a non-perfect square trinomial. And this is the way you identify them, and this is also the way you factor them. If this video was useful to you, just feel free to subscribe and activate the bell in order to receive further notifications. See you next time.